Have you ever looked up at a massive skyscraper or maybe driven across one of those sprawling suspension bridges and just wondered, what actually happens when the blueprints fail? What happens when all that meticulous math, the careful planning, and those layers of engineering somehow just go wrong? It's a pretty catastrophic reality to consider, but for the companies that actually build our world, it is this ultimate, literal life-or-death risk that they have to actively manage every single day.
Welcome to this explainer. Today, we're going to unpack the absolutely devastating realities of structural failure. And we're not just looking at it from an engineering perspective, but from a financial and regulatory one. We'll explore exactly how design flaws and poor construction quality ripple outwards, causing everything from massive redesign costs to long-term legal liabilities. It is a really fascinating look at how the people who fund our built environment measure the hidden costs of failure. So we're kind of going on an iceberg journey today, starting with the visible damage of a structural collapse, and then diving way down into the hidden financial depths that can literally sink a company.
Okay, let's dive into this. Here's our roadmap for today. 1. The weight of responsibility. 2. The consequences of failure. 3. The hidden cost of rework. 4. Legal fallout and liability. 5. Climate change as a threat. And finally, 6. Accounting for structural safety.
Now, to truly grasp all of this, we need an authoritative framework. So our source material today is the SASB Industry Standard for Engineering and Construction Services. These are rigorous sustainability accounting standards maintained by the International Sustainability Standards Board that investors actually use to evaluate a company's risks. So this isn't just theory, right? This is the exact standardized handbook used to quantify the massive risks of designing and building global infrastructure.
Starting off with Section 1, the weight of responsibility.
We really need to ground ourselves in the literal life or death professional duty held by construction and engineering firms. The source material makes this incredibly clear right out of the gate. Entities in this industry have a fundamental professional responsibility to ensure the safety and integrity of their work. I mean, think about the stark contrast here. A construction project is a marvel of careful, precise planning, requiring thousands of hours of architectural and engineering foresight. But when that structural integrity is compromised, like when an error actually makes it from the drawing board out into the physical world, that precision instantly turns into a chaotic and incredibly expensive reality.
Which brings us to Section 2, the consequences of failure.
So, what actually happens when the project design or construction phases contain critical errors? Well, the immediate fallout is severe, and it's multifaceted. The standard explicitly outlines 3 major, visible consequences: significant personal injury, an immediate loss of property value, and broader economic harm. And it's absolutely crucial to remember the human element here. We aren't just talking about a company's stock price dropping. We're talking about physical building failures that cause real, catastrophic personal injury. And from a business perspective, firms that manage this poorly don't just face the tragedy of the event itself, they face catastrophic reputational damage that can permanently cripple their future growth.
Moving right along to Section 3, the hidden cost of rework.
Now, what's really interesting about this slide is we're shifting our focus below the surface. We're moving from the public, highly visible failures into a massive internal financial drain. The standards track this using a specific metric, IFN 250A.1, which measures the amount of defect and safety-related rework costs. Rework is formally defined here as activities in the field that must be done more than once, or activities that remove work previously installed. Just imagine the sheer agony of this for a second. You spend millions on materials and labor to build something, only to discover a major defect or a safety issue. Now, you have to pay to tear down exactly what you just built, and then you have to pay for the labor, materials, and equipment a second time just to do it right. It is a terrifying multiplier on your project costs.
And as you'd expect, investors want to know exactly why this is happening. The standard dictates that companies shouldn't just report the raw cost of rework, they're strongly encouraged to provide context. They need to explain the root causes of the rework, the corrective actions they've implemented to stop it from happening again, and the total financial impact on the entity. This level of transparency forces a company to show investors exactly why these defect-related errors are bleeding capital and stalling their growth.
Section 4, legal fallout and liability. Because, let's face it, when structural integrity fails, the chaos on the construction site inevitably transitions into a massive battle in the courtroom. Under metric IFEN 250A.2, companies have to disclose the total amount of monetary losses resulting from legal proceedings associated with defect and safety incidents. But notice a really crucial distinction here. This metric completely excludes the legal fees and expenses a company incurs to defend itself. It only measures the devastating final monetary judgments. We're talking the actual fines, the civil settlements, the restitution, and even criminal penalties paid out to opposing parties. This tells investors that we aren't just tracking the everyday cost of doing business or hiring lawyers. We are tracking the definitive, legally proven cost of a firm's failure to build safely.
All right, Section 5, Climate Change as a Threat.
Today, we absolutely have to view structural integrity through the lens of a rapidly changing environment. The source material drops this incredibly stark warning, quote, "Compliance with minimum applicable codes and standards may not be enough to maintain and grow reputational value, especially if the frequency and severity of climate change-related events increases as expected." Think about what that actually means. Simply meeting the legal minimum building code is no longer a safe harbor. Climate change is acting as an immediate, totally unpredictable stress test on today's engineering standards. If a firm just builds to the baseline code and then an unprecedented storm destroys their project, they could still face massive legal and reputational liability. They have to proactively meet or exceed new industry standards to truly protect themselves.
Which brings us to our final section, 6, Accounting for Structural Safety.
So how does the industry neatly wrap up all these escalating, multi-layered risks into a readable format for the people footing the bill? Well, this brilliantly illustrates exactly how they do it. Nestled right within the broader SASB metrics table is the structural integrity and safety topic. You can see the exact quantitative metrics we've been discussing, measuring defect and safety-related rework costs and the monetary losses from legal proceedings. It just proves that catastrophic risk, design flaws, and structural failure aren't just abstract fears anymore. They are standardized, highly scrutinized line items that investors watch incredibly closely.
Which leaves us with this final provocative thought. We've seen just how brutally expensive and legally disastrous structural failure can be. And we've learned that standard building codes might not withstand our changing environment. So if minimum codes aren't enough to handle tomorrow's climate, is the infrastructure we are inhabiting today already obsolete? It's a massive question, one that engineers, construction firms, and financial investors will be fiercely debating for decades to come. Thank you so much for joining me on this deep dive into the hidden costs of structural safety, and I really hope this explainer completely changes the way you look at the built world around you.